In this video, I'm going to talk about natural selection, as promised. So, natural selection is one mechanism of evolution. There are others, like sexual selection and genetic drift, which we're not going to worry about. Natural selection is sometimes called the survival of the fittest. This is not necessarily the most useful way to say it, but what this means is that when we talk about fit, it just means how likely are you to survive to the age of reproduction. The more likely you are to survive to that age, the more fit you are. The less likely you are to survive to that age, the less fit you are. And that's all that fit means in this context. It doesn't mean any good or bad, valuable or not valuable. It just means how likely is a certain thing to happen. That's all. So there's nothing inherently superior about being fit in this sense. So what are the elements of natural selection? So there are 4 conditions where when we have all 4 of them, then natural selection happens. And natural selection being one way that evolution happens. And natural selection is believed to be one of the main ways that evolution, in fact, did happen. So there are 4 elements. One is that you have a group of organisms from the same species, and they're competing to reproduce. There are not enough resources for them all to survive. There are dangers in the environment that some are going to do a better job of avoiding than others, and so on. So there's competition to survive and reproduce among the different organisms in the species. And some of the features that these organisms have are better or worse for survival. One thing that's important, and it's important for organisms, single-cell bacteria organisms and multi-cell organisms like us, it's important to be able to detect poison in dangerous environments. So bacteria that are better able to detect environments that are dangerous to them and get away from them are going to survive more than bacteria that are less good at doing that. Darwin took a voyage from England, ending up off the west coast of South and Central America, and in the Galapagos Islands in particular. And he noticed that there were all these finches which are kind of bird, that were very similar, but that were also different in the ways in this drawing we have here, that they had different head size. But one thing he particularly noticed was they had different beaks. And what he noticed was that the different beaks were most effective at eating cracking open different kinds of seeds and nuts and so on. So the shape of your beak for a bird is very important for your survival. If you have a beak that fits the kind of food that's available to you, you're more likely to survive than a bird that doesn't. Blood is very important. One thing that happens is we get cut sometimes and we bleed. Having blood that clots at the right rate is good. You don't want blood to be clotting all the time and clogging up your arteries, but you also don't want it to have just sort of, if you get cut at all, just keep bleeding and not stop. So having a good degree of clotting is going to be a factor that's going to help you survive. Having sharp eyesight is in many situations very helpful for survival. So we have a group of organisms from the same species competing to reproduce. Some of their features are better for survival than others, right? Having the right degree of clotting, having the right kind of beak shape for the food in your environment, being able to detect poison, and so on. The third element is that these features that are make a difference to survival are inherited from, they're passed down from parent to offspring. Normally the offspring just picks up all these features as a result of being produced by the parent. The offspring has a lot of these features. But, and this is the fourth and last element, there's some random variation in the offspring's features. So an offspring might have a somewhat different feature than a parent. So it might be a slightly different beak shape, or its blood clots at a different rate, or, it's better at detecting poisons or worse at detecting poisons. It's not an exact duplicate of its parent. This is mutation. So when you have these 4 elements, then you can have evolution by natural selection. So let's see how that might work. So let's imagine that we have let's just talk about bacteria because it's simple. So, we have antibiotic drugs that we take and they kill bacteria, but they don't always kill all the bacteria. Some bacteria are resistant to some of these drugs, and that's a feature of the bacteria that is very beneficial for the bacteria. And even within one species, like penicillin is or not penicillin, penicillin's a drug. Like streptococcus, the strep bacterium. Some of the strep bacterium in that species or genus are resistant to drugs and others aren't. So let's imagine we have a population of bacteria, all of the same species, and some of them are resistant to antibiotics and some of them aren't. So let's say the green ones are and the blue ones aren't. So the green ones are going to do better at reproducing than the blue ones are because the green ones there are more environments in which the green ones can reproduce, and so after a generation there are going to be more bacteria that are resistant to the drug, right, because they do a better job of reproducing, so there are going to be more of them. And then after another generation there are going to be even more of them, and after another generation maybe they are all resistant to the bacteria. All the bacteria are resistant to the antibiotic drug, right? So in this little scenario, we have there are features that make a difference to survival. There's a group of organisms that are competing to reproduce, and the features that make a difference to survival are inherited. So in that situation, the feature that helps to survive is going to spread throughout the population over the course of several generations of the species reproducing. The ones that survive to the age of reproduction, having the resistance to antibiotic bacteria is going to make you more likely to survive to the age of reproduction, which is going to mean you're going to do more reproducing than the bacteria that aren't. And it could, as we see here, get to the point where all of the bacteria have the resistance. So that's not sort of selection with the first three elements. Group of organisms, some features better for survival, features inherited. But note that in that case, we didn't actually get anything new. There was no change in complexity. It's just that there was a given feature spread throughout the population over the course of time, but it wasn't a feature that was new to the population. In the next video, I'm going to talk about how we can have new features arising, and that happens because of mutation. Mutation is the key element by which we can actually have new features, and new features stack on new features and stack on new features, so you end up with a very different organism many generations later than the organism you started with. So we'll see that in the next video.